My name is Dr. Nilesh Kumarwala and welcome to my YouTube channel, My Smart Class. Today we are going for the second part of the calculation of 13th NMR chemical shift of organic compounds. So first part was the calculation of chemical shift of simple organic compounds like simple hydrocarbons. If you have don't seen, then see my previous video. Okay, I have explained everything in that video. Okay, so this is a revision of that slides. So let's move together. Now we are going for the chemical shift calculation of some complicated molecules. Like in this molecule, we have two functional groups. As we know that we have to use chart for this chemical shift calculation, and here is that chart. So this chart is for the calculation of base value. So this all base values are given of different organic compounds, and this table is for the shift parameter or effect of group like methyl, COCl, CONH2 or OR, OH. All groups are given, and this is the effect of group. If group is at a terminal, alpha terminal, then this value should be taken in mind: alpha internal, beta terminal, beta internal, and gamma. Okay, so suppose we are taking this example. This is a 6 amino hexane one wall. So 6 carbon. For that, the base value, first of all you have to write the base value. So for hexane, here is the base value: 14.1, 23.1, 32.2, 32.2, and 23.1. So here I have written the base value, here base value. Okay, now we have to calculate, or we have to find out the shift parameter. Like suppose we are calculating for carbon 1, this is C1, C2, C3, C4, C5, and C6. For C1, OH group is directly attached to this C1, so it is called alpha hydroxy terminal. This is terminal group. So for C1 we have to see the value of alpha hydroxy terminal shift value. So let's check. Hydroxyl, alpha, terminal, and hydroxyl value is what? 48. So here is a written value 48. For this C2, this hydroxyl group is, if hydroxyl group is here, then it is called alpha. But for this is a, this hydroxyl group is nearby one carbon for C2, from C2. So for C2, this hydroxyl group is what? Beta hydroxyl group. Okay, if hydroxyl group is here, then it is called alpha hydroxy for C2, but hydroxyl group is at one nearby carbon, so it is called beta hydroxy terminal. So let's check the value of beta hydroxy terminal. Hydroxyl beta terminal value is a 10. So here is a 10. And for C3, gamma hydroxy, there is no issue of terminal or internal because there is no bifurcation for gamma, so it is directly given as a -5. Okay, so value is written -5. Now after summation of these two, we are getting for the value of carbon 1, 2, and 3. There is no effect on C4 carbon by OH, so we are not adding the parameter of OH, but this C4, C5, and C6 is affected by amino. So for this C6, this NH2 is alpha amino terminal, and value is 29. Let's see, for amino terminal 29, for beta 11, and gamma -5. Okay, see here 29, 11, -5. Simply summation of this, we are getting this final value of chemical shift. Okay, so by this way you can calculate all are the structure. Okay, in this case C2 and C3 both are affected by OH and NH2 because effect of OH is a near to 3 carbon, 1, 2, 3. So these three are, and for here amino group is also affected by 3 carbon, 1, 2, and 3. So C2 and C3 are the common, they face the common effect by OH and NH2. So what happened, we have to add the summation of like this effect on C2 by OH and effect on this C2 by NH2. So this combined effect is calculated. Okay, so finally what we have to do, we have to do the summation of all this value. Same for the C3. This is the what for C3 means this 1 2 and C3. This C3 have the effect of this OH, but which effect, this effect on C3, effect of OH on C3 is what, gamma hydroxy terminal, and effect of NH2 on this C3 is beta amino terminal. Okay, like this is -5 for gamma hydroxy terminal and 11 is for beta amino terminal. Okay, and this is the base value of butane. Summation of this and this, we are getting 61.9. These three summation, this three summation and this three summation, we are getting the value. So these are the some examples you have to see. One more thing for this carbon. Okay, I am talking about this C double bond O carbon, carbonyl carbon. Okay, so first of all what we have to do, if we have this kind of structure, we have to divide the structure into two parts. Like we are going to divide this structure, one for here, like this is ethane and this is propane. So here is the base value of ethane and this is the base value of propane. So now what we have to do, we have to calculate this shift parameter. This is SP means shift parameter. This is CO. For this case C1, this is what, beta CO internal. For this C2, this is alpha CO internal. For C4, this will be alpha CO. For this C5, it is a beta CO, and for this C6, gamma CO internal. Okay, and that's the parameter is written, and doing the summation of these two, we can calculate, find out this final chemical shift value. Now what we'll do about C3, this is carbonyl carbon, and you can easily find out the value of that carbonyl carbon. I'm showing one slide, one more slide for that, and here is the like CO carbonyl. Okay, and from this we can calculate the, here is the given 195.7 for carbonyl CO. Okay, so by this way you can directly add the value of CO. Okay, so this is for the substituted hydrocarbon. Here are the more examples, just you see and try to solve by yourself. This is a practice for you. Okay, see here again two groups, one is middle, we have to divide into two parts. This is affected by 1 2 3, these three carbon affected by CO as well as this NH2. Okay, and here carbon number 5 6 7 are affected by CO as well as NH2. By this NH2, these are affected by this NH2, and CO has the common effect on both. So try to solve by yourself. Now for the aromatic compounds, now what we have to do with aromatic compounds, so like benzene have the all equal carbons, and the chemical shift, base value of chemical shift are the same, it is 128.5. so if we are having the benzene, all carbon will give the signal at 128.5 delta ppm. Now for the naphthalene, this carbon 1 4 then 5 8, these all highlighted carbons are having the same value and it is a 128.1. Now for this C2 C3 then C6 and 7 means these all carbons having the same value and that is 125.9. Then 4A and 8A, both 7A, both having the value of 133.7. so that is the case of naphthalene. Now for the anthracene, it is have the symmetry. Okay, so Mainly there are the only 4 signal 1, 2, 3, 4. Okay, now from the symmetry you can easily judge that who gives the same signal, like signal of 9 and this will be same. Okay, this both will be same, this both are also same. Okay, so this is a fourfold, so you can see that these two are same with these two same. Okay, so for 1, 4 and this are same signal. Here 2 and here 2 are the same, so they give only one signal. So here is the difference. For C1 130.1 means this carbon will give 131.1, this is also 130.1, this is also 130.1, and this is also 130.1. This C2 is 125.4, so this is also 125.4, this is also 125.4, and this is also 125.4. For this 4A it is a 132.2, so this is also 132.2, this is also 132.2, and this is also 132.2. This C9 having the value of 132.6, and this is also 132.6. So that is a case of anthracene. Now for the phenanthrene, it is a twofold division. So we can say that C9 and C10 are same. 1 and 8 is same, 2 and 7 is same, 3 and 6 is same, and 4 and 5 are same. So total value are 7 values. Like for C1 and C8 both having the value of 128.3, C2 and C7 having the value of 126.3, C3 and C6 having the value of 126.3, C4 and C5 having the value of 122.2. Now this is the 4A and this is a 5A, both having a value of 131.9, C9 having a value of 126.6, and here 10A, and here 8A having the value of 130.1. So there are the base value of all the aromatic compounds, almost all are covered.